Chi-square test in Excel. Please open the table sheet in the practice file where you have built up your Excel practices. Click on any cell in the table and select Pivot Table under Insert. Select the new worksheet. Check if the table range is displayed correctly and click OK. Then, put city in rows and model in columns. In Values, put Model. Please click on the I mark on the right. Select Value Field Settings. In Summarize Value Field by, please choose Count and click OK. Select and copy only the car models A, B, and C. Paste the values. Since we have selected only the car models A, B, and C, the row totals will change. So, we will use the sum function, the sigma mark, to get the total. Autofill. Blanks should be set to 0. This is the observation frequency table. Create the expected frequency table. The structure of the table is the same, so please copy the column and row names from the observation frequency table. Copy and paste by value the totals of the columns from the observation frequency table to the expected frequency table. Copy and paste by value the totals of the rows from the observation frequency table to the expected frequency table. In each cell, put the formula, the total row multiplied by the total column divided by the grand total. Make the row and column totals into mixed references and the grand total into an absolute reference so that they won't shift when copied. Fill all cells by copying with the fill handle. Round to 3 decimal places. The structure of the table is the same, so copy the column and row names from another table. Now, let's fill with the differences between observed and expected frequencies. Here, we will make a formula to subtract the observed frequency from the expected frequency. Fill all cells by copying with the fill handle. Adjust the column width. Adjust the decimal point. If you add all these together, it will be 0. So, we square them. Fill all cells by copying with the fill handle. Divide by the expected frequency to adjust for size. Copy with the fill handle. The grand total of these cells is the chi-square value. To make the 2 in chi-square as superscript, click on Format Cells and select Superscript. The degrees of freedom of the cross-tabulation table is the number of rows minus 1 times the number of columns minus 1. The degrees of freedom in this case is 12. The p-value is calculated using the chi-square distribution right-tailed function with the chi-square in the first argument and the degrees of freedom in the second argument. Adjust the decimal point. The p-value is 0.308, 30.8%. Name this worksheet chi-square. Let's review what we have done. We first created, from the ABC columns of the car models, the observed frequency table. The expected frequencies were then calculated using the marginal frequencies. We took the differences between the expected and observed frequencies and squared the differences. Then, to adjust for unit size, we divided them by the expected frequencies. The value obtained by totaling them all together is the chi-square. The degrees of freedom are calculated by the number of rows minus 1 times the number of columns minus 1. The chi-square distributions have different shapes depending on the degrees of freedom. The horizontal axis is for the chi-square values, the vertical axis is for the probability density, and the area between the curve and the horizontal axis is the probability. The area between the orange curve and the horizontal axis is the overall probability, 100%, with 12 degrees of freedom, and the p-value is the percentage of the area to the right of the chi-square, 13.9 in this case. When the null hypothesis is correct, that is, when x and y are not related, the probability of having a chi-square greater than 13.9 is 30.8%. In other words, since it is greater than the 5% specified by alpha, we cannot reject the null hypothesis. That is, we cannot say that the car models rented are different in different cities. You can also use the chi-square test function to perform the chi-square test. Enter the observed and expected frequency tables as arguments in the chi-squared test function. We get 0.308, the same as before. Adjust the decimal point. Thus, in Excel, if you create an observed and expected frequency table, the chi-squared test function will return the p-value.